Hi, everyone. Welcome to my next talk in the Science and Religion series. So, this is on the science of free will. So, you may be wondering, okay, how is there science in relation to free will? And free will specifically, your ability to make a choice and make decisions without being kind of controlled. So, are you a puppet on a string, or do you actually have the ability to freely choose and make a decision regarding your future and your outcomes? So we're going to look at this in three parts, and we're going to kind of answer three questions. So the first question is the world deterministic? So we're going to look at it from a physics standpoint. Do the laws of nature, specifically cause and effect, determine all the future events? Then we're going to look at it from more of a biology standpoint. Are we so completely programmed by our genetic code, specifically our DNA, that our future desires are beyond our control? So are our desires, our tendencies, our traits predetermined, pre-programmed in our DNA? And then third, we're going to kind of turn a little bit away from the science aspect of this talk and look a little bit more at the religious aspect of this talk. And so, if God, so in the Bible, God kind of knows the future. So, if God knows the future, does it matter? So, say physics and biology both say. So, say we go through question 1 and 2, and it's like, yes, we still have free will. Then, does that even matter from a physics and biology standpoint that we can choose if God already knows the future? So are we kind of determinist, or is it deterministic based on God controlling everything? So let's look at those three questions. So first we're going to look at the physics of free will. So is the future predictable? And so kind of the first statement on this was by Pierre-Simon de Laplace, who lived from 1749 to 1827. Here's a picture of him. And he demonstrated that the future is predictable. And so if it's predictable, then it's therefore predetermined. So if we could predict the future, then it must be predetermined. And he based his theory on the law of cause and effect. So his thought was if we have a given cause, then it always produces the same effect. So then if we have the cause, then we could be able to predict what the effect would be. So if there's a cause, we would be able to predict the effect, in essence, predict the future. So let's look at some examples of this cause and effect that he was kind of thinking through. So on a macro scale, we observe predetermined faith continually. So this is true. On a macro, everyday scale, we do see kind of this cause and effect predictability. For example, if I have one of these big balls, these are kind of the balls that people can kind of get in and run around in, I believe. So if we have one of these kind of big balls and it's released at the top of a smooth slope, then we know the ball is going to roll down the slope. We never are walking out and see the ball rolling up the slope. So in this case, the cause would be gravity. And so we have gravity, and then the effect would be the ball rolling down the slope. That's one example of cause and effect. We know the cause, gravity, and we can actually predict the effect that the ball is going to roll down the slope. Another example of this would be, say you have a cup of hot tea and you just set it down in your room, it's kind of normal room temperature. What's going to happen to your cup of tea? Well, it's going to cool down, right? You don't go back to your cup of tea in a few minutes and go, oh, it's even hotter. No, it's always going to cool down. And this is due to the laws of thermodynamics. So we know that systems go from high energy, so heat being hot, the atoms are kind of vibrating very quickly, so it's high energy, and then it's going to go to low energy where the atoms are moving slower because they're cooler. So the cause is kind of our system going from high energy to low energy. We know that's going to happen. So then we can predict that if it's going to go from high to low, that the temperature would go from a higher temperature to a lower temperature. So we can see a cause and effect. So Laplace argued that what's happening on this macro scale actually functions everywhere. So if we see this cause and effect, then we can also see that on the micro scale and in every aspect of life. So if this were the case, there would be no room for free choice. We would know the cause. If this is the cause, then we would be able to always predict that this would be the effect. However, a few hundred years later, Werner Karl Heisenberg, developed in 1927 his uncertainty principle. And so, what he was doing when he was kind of studying particles and trying to determine, he wanted to be able to determine the position of the particle and its momentum. And so, just a reminder, momentum is the mass times the velocity. And so, what he was able to determine by trying to study and kind of pinpoint precisely the position and the momentum of the particle was that there was a limit to this precision. So, there was a limit to how precise you could be. If you really, really wanted to be very precise on the momentum of the object, then you would have to be less precise on the position. If you wanted to be very precise on what the position was, you'd have to be less precise on the momentum. So you could not accurately measure both aspects at the same time. You can measure one, but not necessarily the other one. And so this was kind of one of the times where the scientific community had to really admit there was a limit to scientific knowledge. We weren't able to understand and measure both as precisely at the same time. You can measure one very precisely or the other very precisely, but not both at the same time. So, if we could measure the momentum very precisely, then we couldn't really predict the position. So, this cause and effect is starting to kind of not be as strong in the sense of a macro scale. So, knowing we're not being able to know the present exactly obviously meant that the future could not be foretold. If we can measure the position, but we can't then predict really where it's going to be next because we didn't have all the pieces of the puzzle kind of idea. So this was Heisenberg's uncertainty principle. And then later, Heisenberg's uncertainty principle was developed a little bit further, expanded by Wolfgang Pauli, Max Born, and Niels Bohr. And this became the Copenhagen interpretation. And so, what this interpretation suggests is that certain properties do not have definite values until measured. So, this idea is that all the possibilities for existence that fall within the uncertainty of the measurement might actually exist. But only when we make an observation does one specific point, at one specific point, do the other possibilities vanish. So, to kind of give you an idea, so say we're really trying to measure the, position. There's all these options of where the position could be. And until we really actually measure and tune in and get down to it, do we actually figure out the actual possibility? So this ended up being the basis for quantum mechanics. Because what was discovered is that particles, instead of really having definite locations, because of this uncertainty principle, if we know the momentum, we can't really know the position. But if we know position, we can't really know the momentum. So we could kind of know, ish, this is their momentum, and ish, in this general vicinity is their position. And so we couldn't really narrow it down. And so what it means is instead of having definite locations, quantum mechanics started to describe particles using probability distributions. So it was saying that, okay, these properties would be within this range in this kind of location, if we're talking about position or this range of momentum or etc. And so what it was found was that objects in the universe have what are called extended fuzzy boundaries. And you might say, the objects are fuzzy. What does that mean? So let's kind of dive into that a little bit more. So what does it mean to have a fuzzy boundary? So being fuzzy means there's no exact edges to measure. So if you want to think about it before, we used to think about the subatomic particles as more like a marble, as you can kind of see in this picture here. So very distinct edges that we can measure. But as we were starting to try to really pinpoint the location of these subatomic particles based on a Heisenberg principle and the Copenhagen interpretation, it was kind of figured out from experimental data that it was actually really kind of more rough approximation edges. So the fuzziness is actually kind of real. So if you wanted to look at kind of a positioning imaging of a subatomic particle, you can see that at the bottom right here picture, and you can see the edges are kind of fuzzy. It's not as clear. You can kind of say, okay, this is about where this is at, give or take a little bit of wiggle room. But as we were to kind of start to, kind of drill in closer and closer and closer to try to get more precise on the positioning, we would learn less information about other things like the momentum. And we would notice that it would actually start, these like fuzzy edges would start to overlap and emerge into this single large entity. And that's how we were able to kind of get pictures like this. So now what's happening is these subatomic particles are now being understood as quantum objects. And so they're going to be described by wave functions that could spread over a region of space. So what we're seeing here is that we really don't have that deterministic environment. So kind of looking at question number one, based on physics, is it deterministic? It's really not. Physics can kind of give us a range of kind of maybe positioning or different values that it can fall into, but it's not deterministic in the sense that it has to be this sense. So you could say kind of from physics that maybe physics determines a box that we have to be in, but doesn't determine exactly what we have to have. So from our first question, I would say that the answer would be that no, we don't live in a deterministic world. We do have some boundaries for that world, but it's not deterministic in the sense of exactly what those options have to be. Okay, so now let's look at biology. So are we so completely programmed by our genetic DNA? So let's look at what biology has to say. So let's look at the information. Where are we getting this information? So every cell of our body, and I just want to add a caveat that there is an exception of a few very highly specialized cells. So there is an exception here. But the majority of every cell of our body has information within it to reconstruct an entire body. So we have one cell, it's going to have all the information in that one cell to be able to reconstruct an entire body. And every cell in our body has that information. And that information is packed into the double helix of DNA. So all that information is in DNA. And just to give you an idea, DNA is a very efficient carrier of data. So to give you an idea of how much information is kind of in the DNA strand, I want you to think about all the information held within the library. So here's kind of a picture of a library. A lot of information, lots of books in this library. Really cool looking library. So if all the information held within all the libraries of the world, so that would be about 10 to the 18 bits of data. If all this information were programmed onto DNA, it would fit on about 1% of the head of a pin. So think about a little like pin. It would just fit on about 1% of the head of the pin. So very small amount of information there in the larger picture of things. And also in the sense of how much space it takes. So it doesn't take up a lot of space for this information to be able to be held in the DNA. Also, to be more precise and to kind of think about it from our DNA perspective, each cell of our bodies has about 3 billion DNA base pairs. And the base pairs are kind of like the pieces of data. You can think about it. Coiled within DNA, weighing trillions of a gram. So it has so much information, only takes up a very small amount of space, and it weighs a very small amount. So 1% of a head of a pin and a trillionth of a gram. So lots of information in a very small space, and small weight. Okay, so what is that information going to tell us? So our DNA is a fixed package. So when we get our DNA, it's not like we can go in and say, okay, I want to pick this for my color of my eyes, this for my skin color, this attribute, this. Like we just get what we get. It's already bundled together and you get it. So it's not like we get to kind of pick and choose what we want in our DNA package. But the question is, okay, we understand that we can't choose the color of our eyes or our skin, and that's not necessarily something related to maybe free will. But can we choose our personality traits? Because that would be more related to free will. Do you have the choice in your personality, how you act? So do we get to choose personality traits such as introversion, impulsiveness, anxiety, any of those? Are they actually controlled by our genes? Does our genes determine our personality traits? Well, to go ahead and kind of give you an answer, and then I'll show you some evidence for this. Genes influence tendencies, but they do not dictate our actions. So it's similar to that physics in the sense that they kind of, point us in a direction, but they don't tell us we have to go that direction. So they might have a tendency, you might lean more to introversion or impulsiveness or anxiety, but that doesn't mean that you have to be an introvert or be impulsive or have anxiety. So they do not dictate our actions. So why would I say that? So let's look at an example. So let's look at fraternal twins and genes. So here is the picture of fertilization. So with fraternal twins, you have two separate eggs that are both then going to be fertilized individually, that then turn into two fertilized eggs. So fraternal twins and also biological siblings have the same fraction of genes in common. So they have about half the genes in common. Interesting, if one fraternal twin is an introvert, so he has a specific personality trait, then it's going to be a 20% chance that both twins are introverts. So if one is, it's a 20% chance that the other one is. However, if we're talking about non-twins, biological siblings, if one of them is an introvert, then it's only a 10% chance that both non-twins are introverts. Now, interestingly, if genes were to be in control, they both, fraternal twins and biological siblings, have the same fraction of genes in common, approximately half. So if that were the case, then the percentages of the likelihood of them having the same personality traits should also be the same because they have the same percentage of genes. But that's not the case. If the genes were in control, the percentages would be the same, but they're not. One's 20% and one's 10%. Well, let's look at identical twins. So here we can see, so identical twins, you have one egg, it's fertilized. Then you have the fertilized egg, and that fertilized egg divides into two fertilized eggs. So here we can see that identical twins actually have the exact same genes. So fraternal, about 50%, identical twins, 100%. So if genes are going to be dictators of our social tendencies, then the identical twins should be socially identical. So when we look, one identical twin, say one identical twin is an introvert, then it's actually a 50% chance that both twins are introverts, not 100%. So if we kind of look at all the statistics here, so we found 50% for identical twins, and on the previous slide, I shared that it was 20% for fraternal twins. So we already kind of know from just general, if you've interacted with twins, that identical twins are generally more similar in personality than fraternal twins. So we do kind of see this 50 to 20% that identical twins are more alike than fraternal twins. But we also see in nature that identical twins are never completely identical. They usually have some differences in their personalities, values, even life choices. So is this a result of nature or nurture? It's really uncertain, but one thing we can see clearly is that even though genetics influences personality, there's a 50% chance, if one twin is an introvert, 50% chance that the other identical twin would be an introvert. So there is some influence there. And we can see that also environment also influences personality. So neither genetics nor environment completely determines our choices. So DNA may shape our tendencies towards one personality trait or one aspect, but it doesn't dictate it. So in this case, it does not eliminate free will. So let's just kind of glance a little bit at what does the Bible say in relation to kind of this idea of the biology of free will. So there is the concept of tendency in the Bible. And the concept of tendency, like human tendency, how we act, tend to lean, relates to the biblical morality that is described in the Bible. So if there is a natural human propensity to an act that is counterproductive to either the individual or the society, there is a biblical command regulating that aspect of life. So if there is a tendency towards something that is, counterproductive, then we have kind of a biblical command of morality. So for example, if there's a human propensity to cheating, so cheating would be one of those acts, then there is a biblical command that forbids that and defines it as an abomination. So you might say, okay, well, it's a very negative one. Well, some people might consider the next one is not necessarily a negative one. A human propensity to being a workaholic, working a lot. Well, there's a biblical command for a day of rest. And so here we see kind of that tendency to do something. So there exists some of these biological tendencies for humans to kind of lean in one direction. But way the Bible addresses this is, okay, well, you have a tendency for cheating or working too much. The Bible doesn't say, okay, well, it's predetermined in your DNA. It's not really anything you could control. No, the way the Bible addresses it is you have a tendency towards these things, but it does not remove the moral responsibility or the possibility of choice. It says, okay, you have a tendency to do these things. You shouldn't. This is what you should do. And it leaves it up to the person to make that choice, whether they want to go with their biological tendency or to follow the biblical command. So based on the Bible, it recognizes that we do have the role DNA has in kind of leaning us towards one direction, but it also says, but you are not free from choice. And so the Bible supports the idea of free will. Okay, so we looked at physics and then we looked at biology, and both of them support the idea that we do have free will and that we do have choice. So let's address our third option. So if physics and biology both allow us for choice and give room, what is kind of the point if God already knows what we're going to decide? Does that mean we really even have free will? So for a lot of people, actually, theology ends up being the ultimate stumbling block. For them, they're like, well, if God knows the future, then do we really have free will? Is he not just controlling what we're going to do anyway and influencing us? So let's kind of look at God in particularly. So based on if God is the creator of everything, the creator of the universe, then the characteristics of God have to include immaterial because he created all of matter at the beginning of Genesis, in the beginning of creation. Spaceless because he created space, created the universe and everything. And he's not bound by time. He should be outside of time because at the beginning of creation is when he created space, time, and matter. So he should be outside of the things that he created. So thus, God exists in what's considered an eternal or unending now. So this kind of eternal period of time, but that eternal now or eternal present includes our past, present, and future simultaneously. So this is kind of a lot of Christian philosophers have argued this idea, but God exists out of time and is in this kind of eternal present. And we say present, but it's really an eternal period of time that includes all of time, which can be a little tricky to understand. So if that's the case, is our future ours to choose, or is our fate predetermined and destined? Are we just kind of, gonna go down that path no matter what? So in Genesis 15:13, it says, and the Lord said to him, and in this verse, the him is Abraham. So, and the Lord said to Abraham, know for certain that for 400 years your descendants will be strangers in a country not their own, and that they will be enslaved and mistreated there. So he's saying that for 400 years, the descendants are going to be strangers in a country. So is this inevitable and certain? Well, apparently not. And let's look at that. So those predicted events occurred only in accord with the actions of the people. So God's foreknowledge did not force Abraham's descendants into Egypt. The prophecy was fulfilled through a series of real human decisions. There were famines, they chose to migrate, and the choice to remain in Egypt. So let's look at this a little bit deeper. So we have Abraham, Isaac, and Jacob. So the Israelites were slaves in Egypt for just over 200 years. But the passage that I just read said, wait, it was 400 years. So where are the missing 200 additional years of servitude? Because it said that they would be in a land not their own. So the 400 years is from the birth of Isaac in Genesis 21 to the Israelite exodus from Egypt 12. So that would be the 400-year span. So how does that relate to this Genesis passage that we just read on the previous slide? So during the time of Abraham and Isaac, and those first two leaders, there were severe famines occurred. We see this in Genesis 12:10 and in Genesis 26:1. So both Abraham and Isaac, in their time of leadership, they both journeyed to foreign lands, and they were there, but they did not settle there. They eventually returned to Canaan. So this matches that Genesis 15, that they would be, foreigners and strangers in the land not their own. However, during the time of Jacob, they also had severe famine occurred. Genesis 41:54 shares about that. And Jacob and his family, they also journeyed to Egypt. But instead of returning eventually back to Canaan, they ended up settling there, as seen in 27. So God had sent Abraham out of Mesopotamia to settle in Canaan. And all the time that his progeny remained true to that charge, they were strangers in the land of Canaan, a land not yet their own, but they were free from bondage. However, Jacob's children changed the pattern. They abandoned Canaan and settled in the land of Egypt. In doing so, they set the stage for their eventual enslavement in the foreign land. Had Abraham or Isaac settled in the lands to which they journeyed during the famine and didn't return back to Canaan, then much more of that 400 years would have been in bondage. So it was 400 years of them living in a land that was not their own, but only 200 of it ended up being when they were slaves. And so there was some kind of foretelling, but not exactly determining all of the conditions of what it would look like. Another example from the Bible regarding free will is the story of Esther. So in Esther 13 to 14, Mordecai, which is Esther's uncle, replies to her saying, so at this point, Esther has the choice to kind of save the Jewish people by kind of stepping up, speaking to the king, and kind of helping to save the lives of all the Jews. And so Mordecai tells her, do not think in your heart that you shall escape in the king's house any more than all the other Jews. For if you remain silent at this time, then relief and deliverance shall arise from another place, and you and your father's house will be lost. So she had the decision to approach the king, which could, cost her life, to approach him without being called on. But if Mordecai is saying here, but even if you don't do that and you think, okay, well, you're in the king's palace, even though you're a Jew, you won't be killed. That's not going to be the case. God will save the Jews from another way. And so Esther had the choice. She could either kind of follow along and go and talk to the king and kind of save the Jews, or she could choose to remain silent. And if Esther had chosen to remain silent, that God would work through someone else. So we might be reading the book of Yael or Hadass or Hannah instead. Esther would be forgotten. But the Bible makes it clear that our choices affect our futures. So her future was not predetermined. It was up to her to determine, would she speak up and save the Jewish people, or would her father's house be lost? Would she be kind of silenced and forgotten about if she had not chosen to speak up? So those are just a few cases from the Bible of God being outside of time. But we also kind of want to look at, what does it mean for God to be outside of time? So being outside of time means a flow of events has no meaning. So for us, we have a past, we have a present, we have a future. There's kind of like a flow of events. We're a baby, we become a child, we become an adult, and then we become an elder. And so there's kind of a series of events and a flow. But if you're outside of time, then you don't really have that flow of events or meaning. The future and the past are all present, all at the same time. And it's interesting that we can actually see this concept of this eternal now or eternal present in the actual name of God. So in Exodus, God gives his name, and he's saying that my name is I am. And this is a four-letter name for God. And in Hebrew, it includes the letters of the verb to be. And it's actually written in the three tenses. So in God's name here, in the name that he shares, his name actually means I was, I am, and I will be, all at the same time. So in his name that he provides, it is also the past, present, and future, all contained within one name, contained in the eternal now. So it's interesting that God is kind of expressing in his own name how he relates to time and situations. So how does that work scientifically? How can we have an eternal now, in a kind of eternal present that has the past and the future and the present all together? So Einstein has a theory of relativity, and it demonstrated that the faster one travels relative to another object, the slower time flows for the traveler, relative to the flow of time, measured by the stationary observer. So, what Einstein is trying to say here is that if one object is moving very, very quickly, if the other object starts to kind of match that speed, then the flow of time kind of starts to slow down very, very slowly. Now, the speed of light, which is the highest speed attainable in our universe. So at the speed of light, time ceases to flow altogether. Because which we're not able to, but if we were to match the speed of light, then our perception of time would cease to exist. Okay, so if we're traveling at that time, we're matching that based on the theory of relativity, then our time flow would cease to exist altogether. And so at the speed of light, the time of all events becomes compressed into the present, an unending now. So at that point, you have past, present, and future kind of all compressed together because time kind of ceases to flow. So the creator, existing outside of time, knows the ending at its beginning. And it's not because the future has already physically occurred within our realm of time, space, and matter. It's because of this idea of him being outside of time and being able to have that compression of all the time events. Now, it's interesting that this is related to the speed of light. And light has a interesting connection with eternity. So, if we looked at the beginning of the Bible, light was the first creation of the universe, which is rather interesting that this is the first thing that God creates. As we just talked about, relativity suggests that light occupies a unique place in our understanding of space and time. Because of the speed of light, if you were able to match the speed of light, then time would cease to flow altogether. So the relationship with light and time is an interesting, unique relationship. And this link between the timeless eternity that preceded our universe, so before light was created, before space and matter and time was created, we had this timeless eternity. And now, once it was created, we have the worlds of time and space and matter, in which we live. And light is kind of that link before those two things. It's interesting that that's kind of where God began. So, to close, we looked at these three questions. Is the world deterministic? From a physics standpoint, the answer would be no. It does kind of direct us maybe keep us in a box per se, but it does not determine exactly what needs to be answered. What about our DNA, our genetic code? That means that we are programmed to be a very specific person? The answer would be no. It kind of leans us in one direction and the other, but we still have our choices. And if God knows the future, does that mean that we don't have free will? And based on how the Bible presents our life of the lives of people before us, it shows no. And based on our understanding of time and space and God being outside of time, we can see how he could actually know the future and how that knowledge doesn't actually impact our choices and our decisions. So sometimes we think, okay, because God knows the future, that automatically impacts our choices. But based on Einstein's law of relativity and our understanding of God's relationship to space and time, we can see that actually he's outside of all of that and is living in a time where he can see all of it at the same time. And so it's not that he influences it, it's he already kind of is seeing it and acknowledging it. So I hope this gives you a little bit more kind of things to kind of chew on and think about in relation to free will and how does that impact you. So I just want to challenge you to kind of think about this and see how would that impact your future choices and decisions and the consequences or effects that your choices and decisions might have. Thank you so much for coming to my talk. Here are just a few references from that talk. And I hope you join me in my next talk.